So now we are on to this slide. I'm not going to give you guys the handout, but we want to tell whether it's going to be the dilation is either a reduction or an enlargement, and we want to find that scale factor. So our original is from C to P. So from C to P prime, is that going to be it's going to be an enlargement because it got bigger. Before we find that scale factor, let's talk over here. If we're looking at number 2, and we had our original CP, C to P prime is that going to be a reduction or an enlargement? It's going to be an enlargement. Oh, no. I followed you blindly. Okay, so from C to P to C to P prime.
Oh, that's a reduction.
So it's going to be a reduction. Sorry about that. I just repeat what you said, so I apologize. Okay, so now we are going to find that scale factor. So what did we have for our scale factor formula on the last slide? C over. So we have CP prime over CP. So CP prime is what distance? 10. I'm going to write here and I'll move over to to CP, which is just 5. So that's going to be, which holds true, right? It's an enlargement, whole number. Okay, over here, we have that same formula we're going to use. So we have CP prime over CP. Okay, so, CP, he just told us is 8. Our CP prime is 8. CP is
24.
So 8 over 24 reduces to 1 over 3. And that holds true because a reduction fraction. The scale factor that is true for one part of the image is true for the whole image. So we have CP prime to CP, and we want to figure out how to relate it so that we can solve for x. So the way we are going to do that is we are going to write Q. Oh, sadness. Here we go. Okay, so we have Q prime, R prime, over QR. So that is Q prime, R prime over QR. So we had our QR, which is the x that we're looking for, right? And then Q prime, R prime is the other value we know. They're the same side of the shape, so we can see that there's going to have that same ratio occurring. So now we're going to substitute in what we know. C prime is what value? C to P prime is what value? 8 over 14. And then we have Q prime to R prime, which is over QR, which is x. Now we're going to do what we did in our bell ringer, or cross multiply. So I end up with 8x equals 6 times 14. I'm going to divide by 8. 8 goes into 6 or 14 evenly? No. So I'm going to take out a 2. So 2 goes into 8 4 times. 2 goes into 14 how many times? 7. And then 2 goes into 4 how many times? 2. And 2 goes into 6 how many times? So 3 times 7 is? 21 divided by 2. So you can either write x equals 21 divided by 2, or you can do the decimal answer. What is 21 divided by 2? 10.5. So let's recap this one. You had to find a relationship. We know the original and the image here. They were both on the same side. So we had CP to C prime, or C to P prime. So that's our relationship that we know. That's the ratio. Then we have to relate it to what we want to find. What we want to find is x. So we had to find what is the smaller version of that, since that is our biggest. The smaller version is what's right in here. So that's at 6. And that's the ratio we created here. And then we cross multiply, divide it, and solve for x. Okay, so we want to find the value of the variable. So with this, we have to create that ratio ourselves, right? We don't know which one. Well, in some of them we do, but we don't always know which one is the image. So we have here where it tells us it's P prime. So remember that P prime went on top. We don't necessarily have to write it that way. But so C to P prime went on top. Come on, Jenkins. Okay, C to P prime over CP. And so C to P prime is what distance?
20.
It's 20. And then we have C to P, which is what distance? 8. So that's the ratio we found based on going from C to P and then C to P prime. We want to relate that to find our M value. So here you saw I wrote my biggest portion on top. So I'm going to write my biggest portion on top of this one. So the biggest portion I'm looking for is M. So I'm going to relate it to M over the smaller same side, which is 2. So are you guys okay with how this worked out?
Yes.
Okay, so now we're going to cross multiply. So we get 2 times 20 equals 8 times M. That gives me 40 equals 8M divided by 8. M equals what? 5. Now, if we did not notice that there was a prime here, that's okay. We could have done this by just creating a ratio where we either put the smaller numbers on top or the bigger numbers on top. So we could have done this 8 over 20, 2 over M, and it would have solved the exact same way. So our next one, if we're going to follow that C prime to, let's actually do it this way. So this one, let's follow using just creating that relationship. So we have the distance here of N, and we have a distance here of 4 that relate to each other. And then we have a distance 3 and a distance 6 that relate to each other. So here, all we have to do is we have to create a relationship between them using fractions. So I know I have 3, which is my smaller number, so I'm going to write it on top, over 6. The 6 is the same side, but just bigger, right? So it's the relationship-wise, they relate to being the same. Over here, I have the size N, and it relates to 4. So I'm going to make N over 4. Now we're going to solve. So we have 3 times 4 equals 6 times N. Divide by 6. 3 times 4 is? Divided by 6 is? So N equals 2.